today Prysmatic Labs coming to Ethereum Sao Paulo. We're a group of developers eager to learn more about this new architecture of ETH 2.0. And it's a pleasure to have both of you with us today. I would like to pass the ball probably to who would like to start. Terence, maybe you? And then we pass to Preston. And also to everybody here, you're very welcome to ask your questions in the chat. But in the end, they will open for Q&A as well.
Sounds good.
So welcome to Sao Paulo Meetup.
And
You looking for your slides, Terence?
Slides, I'm just trying to press the Preston button and then try. Let's see if this works. Can you guys see my screen?
Yes, it's going to show shortly. We can see the beacon chain and the Prysm high level.
It shows up. Okay. If 1 or 2 minutes, and yeah, let's get started. So I will level-wise chain is, and then so usually I like to start by introducing ourselves. We're Prysmatic Labs. We are a team implementing Ethereum 2.0 protocol written in Go. There's Rahul, there's Preston, there's Ivan, myself, Nishan, and then the contributors out there. And special shout out to them as well. And are you just able to hear me okay? I'm looking at the chat and there's people that's having bad connections.
It was really bad in the beginning. Now it got better. So it was horrible.
Okay.
And now it's clear again. But so far, so
okay. Cool. Okay, sounds good. I will watch the chat just so okay. Okay, so let's dive into ETH2 beacon chain. So this is a high-level architecture. You have the ETH1 chain, which we love, and there you have the beacon chain, and then you have shard chains. So beacon chain sits in the middle, in between the ETH1 chain and the shard chains. The beacon chain is used by validators. There's no users on there. It's the chain that keeps validator honest. It's the chain that keeps the validators balance and rewards secure. It's in the future, it will also be the chain that's facilitate cross-shard communication. So for example, if you want to send a transaction from shard 1 to shard 2, you will go through the beacon chain. So it's the single source of truth, and it enables a lot more features down the line. So like I said, this is what beacon chain has validator registry. So that's where the validators accounts are. So validators register to the beacon chain via a one-way deposit through the deposit contract. It's right now it's set to 32 ETH to join. And then if your ETH fall below a certain threshold, you will be ejected from the validator registry. And to prevent fraud, to prevent validators to manipulate against each other, this beacon chain has pure randomness. So we use Randolph for that. And in the future, we'll also have VDF to basically make it unbiasable. And the beacon chain tracks the rewards and penalties of the validators. So the rewards and penalties are calculated at every epoch. And there's also this inactivity penalties, which if validators doesn't perform or offline for a while, their penalties gets increased quadrilaterally. And then another special thing about this beacon chain is that it has finalization built in. So it's essentially this nice property, this nice BEFT property that if 2/3 of the validators agree on something, that cannot be reverted unless the 1/3 of validator state gets slashed. So the protocol we use for that is Casper FFG. Highly recommend people to read that. It's very informative, very nice. So Beacon chain has two main objects. So there's Beacon, there's blocks and there's state. And then just like Ethereum, just like the current Ethereum block, there's the block within the block. It has fields. It has parent root, which that's how you link back to the parent block. And that's why it's a blockchain, because it's a chain of blocks, right? And then it has the state root to ensure that the state matches the outcome after applying this beacon block. Yes, the signatures, without the signature, you cannot verify the block. And within the beacon block body, it has multiple fields. And those fields I will get more into later, but these fields are used by validators to keep each other honest. And then they're also used by validators to essentially give each other rewards and penalty. And on the right-hand side, you have your beacon state. So those state are essentially just like the current Ethereum 1 state, but this state is essentially used by the validators. The validators are really interested in what they can get from it. So just like a typical peer's state transition function, you apply the beacon block to the state, and then you mutate the state, and then you get the new state back. So here we apply the beacon block to the beacon state, and then it essentially does verification. And during the verification step, if it failed, then the block is bad, and then you just throw the block away, and then the state stays the same, which is pretty easy, right? And if it passed, then the block will essentially mutate the state, and then you will get a state. And then you do that for every slot, just 12 seconds in the current spec. And then after you process the block for 32 slots, which is about 5 minutes, you process the epoch. So processing block is different than processing epoch. Processing epoch happens because of the block, because you process rewards and penalties of all the validators. Finality I mentioned earlier, you look at whether validators has performed bad, so you can slash the validators. And so this path takes a longer time, so therefore you only need. And then I would talk different. Hi, can you guys hear me? Did you lose me?
We did, and now it's like you're coming back again. But you were explaining the difference between processing epoch versus, and then we lost you.
Yeah. So okay, so let's go back to processing epoch. So process. Because this is a and the finalization, which is FFG property mentioned earlier. I said don't do this right, to do this for 6 minutes. And can you guys hear me now?
Yeah, yep.
Okay, cool.
Yes, maybe.
Okay, I just switched to better Wi-Fi 5G, so hopefully this is better. Okay, so let's talk about different validators roles. So this is, and let's talk about different validator roles. So now we have the attester, and then a tester essentially votes for the canonical view of the blockchain. So there's blocks and there's votes. So a tester basically votes on which block that he thinks that is right. So there is different type of votes. So within each vote, there's three components. You essentially can vote. You vote for fork choice. You vote for finality gadget, and then for the phase one, you also vote for the shard data. And then for proposer essentially proposes block. And then the Bitcoin block is really special because it contributes to the randomness. So every block has this seed, and then you XOR or with the historical blocks, and that's how you get randomness from it. And then you also chooses the best ETH1 chain reference. That's how Bitcoin chain links with the ETH1 chain. And then it collects and then packs the Bitcoin operations, and then you put that in the Bitcoin blocks. So that's how the attestations, the votes, the validator deposits basically gets broadcast to within each other. And then you also have this role that's called the aggregator. So there's so many votes in the network, right? It's just really spammy. So then there's this. So what aggregator does is that for ETH2, we use this cryptographic scheme. It's called BOS, aggregation signature. So all the votes could be aggregated, and then the signature could be aggregated as well. So therefore, we have this nice property that in order to process, let's say 128 votes, 128 attestations, you'll need to process one attestations and verify one signature. So that's really nice. So what are the incentives, right? Why do you want to be a validator? So you want to be validators because of you can make money. So then there's different type of rewards you can get, right? So for a proposer, you propose a block, you can get a Bitcoin block reward. And then for a tester, if you want to vote on chains, you can get different rewards for voting on the right things. And that's how you incentivize this Bitcoin chain to essentially be secure, and it has the liveness and the safety property. So let's talk more about fork choice. I did mention LMD goals earlier. That's the fork choice that we're using in ETH2. So the problem here we're trying to solve is that different validators can produce and receive blocks at different times. And sometimes they may be offline, so they have different views of what the blockchain looks like. So how do the nodes come to consensus on what is the canonical chain, what is the final chain, right? So for Bitcoin and proof of work, we use the longest chain. But then here for Ethereum proof of stake, we don't have proof of work, right? So we have stake, so we have votes. So then that's how validators votes, and based on the validators voting, you decide what is the canonical chain. So we use LMD goes for choice rule. So essentially, validators votes on the block, and then you can imagine it like a block tree, and then you follow down the branch that has the most vote to it. And I highly recommend reading Vitalik's paper, Casper on CBC, and it has really good explanations there. So besides LMD goes for choice, there's also the finality gadget. So essentially, it leverages the finality property of the Casper proof of stake protocol. So it only generates finality once the condition is met. And that condition is essentially have 2/3 of the validators voting on that single block. So once it's finalized, it's in the canonical chain forever. It cannot be reverted. If there's revert, then there's mathematical proof that 1/3 of the validators has contributed to a slashing offense. That means that 1/3 of the validators will get slashed, and they will lose between 1 ETH to 16 ETH, and they will get kicked out. So you can use finality gadget to essentially finalize ETH1 block, and there's a lot of talk in the future to do that as well. So that was very high level of what ETH2 as a Bitcoin chain conceptually looks like. There is proposer, there's the testers, they essentially produce block and vote block. there's the for choice. With the for choice, you know exactly what chain to follow. And then with the finality gadget, you have this nice safety property that you know exactly you can follow that chain unless 1/3 of the validators get slashed. So let me quickly talk about our ETH2 client. So essentially, this is the client Prysm that's written in Go that implements that protocol. So for Prysm, we have two different services, software, you can say. There's the beacon node and there's validator client. So the beacon node is similar to the current ETH1 node, but more and more lightweight. The beacon node maintains the state of the beacon chain. It has P2P stack, network stack, so it also gossip, communicate with other beacon nodes, and then we respond to validators' queries. So beacon node essentially is stateful, and then essentially you need to run one to basically get the latest info of the beacon chain. Versus validator client. Validator client is a lot more lightweight. It maintains the private and sensible information, such as your signing key. So essentially, you don't want to lose the data, right? If you lose the data, then people can be signing on your behalf, and that's bad, right? And the validator talks to the beacon node to basically perform this operation, such as like, hey, beacon node, I am a validator. I need to do my work. Can you tell me what to do? So then the beacon node will tell the validator, be like, hey, you have to propose a block at this slot. You have 5 minutes to do that. Then the validator client will wait for 5 minutes and ask the beacon node again for the block. And then you will sign the block and then return back to the beacon node. And then beacon node will broadcast the block on validator's behalf. So here we do assume there's a trust between validator beacon node and the validator client, right? As a validator client, I would not go talk to the beacon node that I don't trust the beacon node. But this is nice. Now you can have a validator client. You can run multiple keys. You can run multiple validators. You can run multiple instances of validator. For example, in my setup, I run between 1,000 to 4,000 validators, and the validator client is really lightweight. And beacon node is pretty lightweight as well. Right now, I'm about like 2 GB of RAM and very small DB usage. So this is a high-level beacon node architecture. Essentially, you have we use the surface. We essentially use the service injection model. So there's different services right there. There's for choice. There's state transition. There's this operation pool. Basically holds all the votes. It holds all the operation data, and then you have your DB. You have your cache. Versus validator is more lightweight. Validator is essentially just a key manager, and then it holds the private key security, and then it essentially has this slashing protection DB just to protect the validators from getting slashed. And then it also runs an RPC client to talk to the beacon node. So right now, validator talks to the beacon node via gRPC, and but then we also have HTTP proxy gateway as well. So we support JSON over HTTP as well. But yeah, we have an Ethereum API repo. I highly recommend you guys to visit this. So this is to standardize the common APIs for the beacon node and the validator RPC server. And then essentially it's a central repo, reduce disparity between services across ecosystem. And if you guys have visited the awesome Beacon Block Explorer by Etherscan and Bitfly, they also implement this interface as well. So this is a good place to start if you want to implement like a hackathon project or like stuff like that. And then this is just the documentations. You guys can take a look at that later. And then we use a bunch of open source components such as BoatDB, DP2P. We have a public RPC server that implements gRPC, and then we use Prometheus and Grafana for monitoring. And then to become a validator, essentially, like I said, you have your user wallet in ETH1. You send 32 ETH to the deposit contract. And then the beacon node listens to the deposit contract. And then after certain slots, it essentially creates this new validator account in the state. And then this is a validator lifecycle. It's very lightweight. You connect, essentially, the validator talks to the beacon node. You wait for the chain start event. you check if the validator has been active. Once the validator is active, for every epoch, it updates its assignment, and then it does the job. And that's all from my end. And I'm going to pass it to Preston. Preston will go in more depth on testnet stuff.
Cool. Thanks, Terence. Let me share my screen. This one. And then present. Okay. Cool. So thanks for Terence. Thanks for giving us that kind of high level and in-depth overview of the Beacon chain and sort of phase one and kind of how ETH2 is coming together. What I'd like to talk about is our process. So how do we take these research ideas and turn them into implementation? And then we'll follow up with a bit of progress updates and our roadmap to come. So starting with research to implementation. So the way this works in ETH2 is we have this sort of waterfall model where we, as implementation teams, work very closely with the ETH2 researchers, which are a group of people mostly within the Ethereum Foundation. They're coming up with new ideas, exploring different avenues of how can we design a very secure and scalable ETH2. Then, of course, we're giving feedback either on the research forums, in person, or on online channels. We will also often propose changes to the specification. Terence is one of the top contributors to the ETH2 specification if you look at the number of GitHub commits. And he's not part of the research team. He's just very dedicated and very involved with research. So that's a really cool part of the first part with the research. Then it comes down to review from other researchers and implementation teams. So when a new idea comes in, everyone's going to take a look at it and sort of give that a go ahead. And then every so often, a new version of the specification is tagged, and that sort of becomes a target for implementation teams. So once we have a release target, we will start working on designing new features to meet that new criteria. We'll see these features come through GitHub, and everyone within the Prysmatic Labs team is reviewing our pull request. Everything has a lot of eyes set on it, so we're making sure that we're doing everything correctly. Taking a look at specifically our feature lifecycle, a very common order for us is to write down a technical design document. And this is really important for non-trivial features so that we can get some early review from other members of the team without having to commit a lot of code and having potentially to start over if we find that there's a more optimal way to do it through feedback. So once we have the technical design doc, we'll break that down into smaller tangible tasks and create what we call tracking issues. So these are issues on GitHub that list out all of the things that need to be done. And that way we can break up the work across the team, or if other open source contributors want to take a piece, we can all work on it together and we can sort of track the progress within GitHub. With that tracking issue in place, we start working on implementation of each of the features. The features get run through pull request review, so everyone's looking at the code, and we do what's called canary analysis testing, and finally a feature will go through its release. So we'll talk a little bit more about canary analysis testing and more here. The philosophy at Prysmatic Labs is that everything must be tested all the time, no matter what it is. So we start with unit tests. So we take a piece of logic and we test it as a small unit, giving a specific input criteria and expecting a specific output result. That's really important for critical arithmetic operations and other things like computing balances or rewards or penalties or things like that. Following that, we have a set of tests that are driven by the Ethereum 2.0 specification itself. So there's a set of test data that all the implementation teams are going to run and make sure that we conform to at least the happy path of the ETH2 specification. Something we like to do is called mutation testing. And this is when we have some automated system change the logic within our production code and expect a test to fail. So if we had something that said, if proposer 5 proposes a block, give proposer 5 1 ETH, and we change that to, if anybody proposes a block, we'll give them 1 ETH. If we only had a test covering proposer 5, well, that means we don't have great test coverage, and the mutation testing will catch that. The next layer that we have here is called fuzz testing. This is randomized inputs with coverage detection. So it's trying to find inputs that go farther into the code and find new features. This is important for finding fatal conditions, things that might crash the application with inputs that we had not even imagined. So that's really helpful for us. We also do integration tests and end-to-end tests. So with every pull request, we stand up a small test net and run it for, I think, 5 epochs, just to see that things still work, that the chain would still start with these new changes. And finally, we'll do what we call a pre-production soak. So this has to do with our canary testing. We'll run the new features and new code with some production traffic and check this against the previous code and make sure there's no major regression. With this, we minimize the risk of total outage, and we're able to see, okay, well, this code's going to work. It'll pass that sort of sanity test there. And what we get out of all of this is we get peace of mind. The code that I've written, it works, and I can prove it because look at all this stuff I did. It's there. This really keeps us safe and keeps us ensured that our code is working as intended. So taking a look at canary analysis and really our deployment pipeline in general, it's grown to be quite complex since we started. When we first started this, it was just manual deployments and somebody pushing out a new Docker image whenever it was ready. And now we do deployments from master. So whenever there's a new commit to master, we'll start a deployment which goes through this whole process. First of all, we make sure it's not a weekend. We don't deploy on weekends anymore because we are trying to have a life. Things used to go wrong all the time. Not so much anymore, but we were getting really tired of our weekends getting interrupted. So now we're only releasing on the weekend or on the week. Then we create all of the new manifests that are going to be deployed. We deploy the previous code and the new code side by side, and we do this canary analysis where we do the regression testing and make sure that there's no big differences. And then if that all works, we roll everything out to production. So taking a look at a canary report, here's an example of what we're talking about. In this new release that's coming up, we see that there is 5% more memory. Now, this isn't a very too alarming number because there might be some natural deviation in the type of traffic these two are receiving. But if this number said 50% more, then I would be kind of concerned, and the deployment would stop and we would have to manually look at it and make sure there's nothing too crazy going on. Maybe we're over caching or something like that. So these kind of things are really important that are really hard to test with unit test or any other kind of testing, something you can only see in production. This has been super helpful for us. Okay, so now we have a rough idea of how features go from research to implementation. Now let's take a look at the Prysmatic Labs roadmap, starting with our very first Ruby release, which we had created in 2018. So in 2018, in October of 2018, we released our first demo of ETH2. This is sort of a proof of concept. It had a lot of gaps where we weren't doing signature aggregation just yet, or even verification just yet, but we had the bare bones of something that resembled ETH2 as we thought it would look at the time. And from there, we learned a lot about our development processes and the changes, and then the spec was changing. So through that, we were better off to start developing our Sapphire release, which took us just over a year, maybe a year and a half, of really getting it down and just really making sure that when we're getting ready for this next release, it's not just a proof of concept, it's the real thing. So Sapphire is our first real tangible ETH2 release, and it marked our testnet that we released earlier this year. In January, we had 52,000 active validating keys. We ran this for 4 months, and it was an incredible success for the most part. We learned a lot from community feedback. We got a lot of support from our users. We got a lot of new contributors. We had developed this network to be mainnet scale, but using only a fraction of the deposit. So when we were building this, we had no idea really what was going on until we started seeing block explorers come up. So this is one of the biggest achievements that's come out of the Sapphire testnet. We got an open source block explorer from Bitfly called Beacon Chain, and then we have our Etherscan block explorer, which has been super helpful. These guys started building in the end of 2019 or mid 2019, and when we had released Sapphire, this is a really valuable tool. So that's been really cool. And now we transition into Topaz, which is our most recent release. It is the current testnet running. It has a lot of new exciting things. It's running on the 0.11.1 specification of ETH2. So this is pretty much the final thing. There's only a few more minor tweaks that are going to be released in the next couple weeks. And then we'll restart Topaz and get all of the last things fleshed out for mainnet. This one is different because it's using 32 ETH deposits. So this is everything mainnet configuration. There are no substitutions or shortcuts. This is full mainnet. So the Sapphire one had a fractional deposit. It only had 3.2 ETH, but this is a full 32 ETH. Some other cool things we have caching of our simple serialized for the beacon state. That's been really helpful. And now that we've enabled it by default, it was causing a lot of issues, but then we fixed those, and now it's helped reduce resource usage significantly. We have a much faster serialization that's now enabled by default, and that's really exciting because it was written by an outside contributor, which we had found through the Gitcoin bounties network. So we actually paid them through a Gitcoin bounty, which is really exciting. Even more Topaz features. This network has dynamic attestation subnet subscriptions. So what this means is that if you're only running one validator, you don't need to be connected to all other validators in the network. You can be connected with a channel that has to do specifically with your committee. And this saves a lot on your network traffic. We've also taken great strides in improving the initial synchronization. I was thinking Prysm this morning, and I was getting somewhere around 60 to 70 blocks per second. When we started Sapphire in January, you were lucky to get like 3 blocks per second. So it is a significant improvement. And there are even some new changes in the pipeline that have pushed this number well over 100 blocks per second. So we're seeing initial sync get easier and better, and be a better experience for users to onboard. So that's really exciting. We have new state management, which is helping with a lot of resource usage. We also have a slasher running in production to catch slashable offenses. Now that's a key component of ETH2, because part of the proof of stake concept is that you have something at stake, and you need to, and validators need to be held accountable for trying to manipulate the system. So having a running slasher in production means that we can test these kind of scenarios where users are either intentionally or accidentally trying to manipulate the system, and we can see that picked up, where the whistleblower will get a reward and the validator will get slashed. So that's really exciting. Right, this launched on April 17th, and we've had 33,000 deposits. So that's really cool. It's almost a million Ether. This balance number here is not accurate because we recycled the ETH. So check out the latest on the Beacon Chain Block Explorer or Etherscan's Beacon Chain Block Explorer to see what the current number is. These are some of the features. Okay, this is a duplicate slide, so we'll just skip it. So talking about what did we learn about these testnets overall. So we've kind of learned a bit about how to iterate and how to do better, collecting user feedback and iterating on that. But some of the key things we learned are how to keep the network running. So at first, we had a really hard time keeping the network alive. It would only last for a few hours, and then it got better. It only lasts for a few days, and then it got better. It only lasts for a few weeks, and now it's unstoppable. So having some of these key concepts have really been helpful. So having excellent metrics and monitoring. This is an older screenshot where we were only running 500 validators, and we could sort of see a deviation in validator balances. So nodes weren't agreeing with each other. We set up alerts for this. We would wake up in the middle of the night and kind of check it out, see what's going on. We could also validate our intuition. So if we thought, okay, hey, I think there's a lot of reorgs happening as the number of peers increases, what we could do side-by-side queries and kind of, take a look and see if there was a correlation or not. And in this example, there wasn't, but I was able to answer that question using Prometheus and having all this metrics monitoring and collection. It's really helpful for when things go wrong. Here we can see memory usage and CPU climbing, going out of control. We can see reorgs going wild. There's 100 for one node. Some of these nodes are running with 200,000 Go routines, so parallel routines are running out of control. Deviation imbalances, just everything is a mess. And we wouldn't be able to see this by watching logs because things would be moving too quickly, but having a visual has been super helpful. And here's a more recent screenshot taken last week, I think, where we can see a nice graph of CPU usage and memory usage. We can see a good participation. We can see that there's no gaps in finality and that our requests have 100% success rate. So we've come a long way with this. There's even new community dashboards out there that help for individual validator analysis. So check out our documentation page. You should be able to find it there. Another key thing we learned is that having instrumentation is a great way to understand where your bottlenecks are in the application. So here we can see a request where a validator is going to update their assignments or update their duties. And that request took 1.17 seconds. And we want to understand what took so long, so we can see that at least here there's a 314 millisecond processing time for process epoch. Maybe there's something that can be improved there. We can go fix this bottleneck. So that's been really helpful. And here's a specific example on when there's an error. We can detect these errors and kind of see what happened and why it took so long. Here's another technique we use with trying to figure out how long things would take. We'll use a protocol called pprof and generate what's called a flame graph. This graph shows the most expensive and time-consuming methods in the application. So here we can see that something is taking a long time with process epoch, kind of just like we saw with the instrumentation. We can see this database fetch takes a long time, and we can sort of drill down and figure out where the problem is. Another thing we learned is that we need a really well-defined application API. So we've developed this Ethereum APIs that Terence touched on a little bit. It's this central repo that we've created to host all types of interactions with ETH2. Currently, it's just Beacon Chain, since that's all we have in ETH2 at the moment. But this repository and host of definitions will be growing over time. So definitely check that out if you're looking to build on top of ETH2. That will be a place to go for sure. This is a duplicate slide. Sorry about that. Block explorers are super cool, though. We also got ETH2 stats. This is a self-reporting dashboard where you can be running your Prysm node, and you can show up on this list, and you can see how you're doing compared to other people self-reporting. So that's been really exciting. Participating is really easy. Just go to prylabs.net. The faucet there will give you some test ether to join. There's really detailed instructions. And we're always happy to help, of course. Join us in Discord. We can help you with that. And so coming up next, that's kind of where we are so far. What's coming up next? Well, we're going to have a coordinated, large-scale, multi-client testnet. That's one of the requirements to launch. We have a small-scale multi-client testnet, which we're kind of working out these bugs. And as we talked about before the meeting, there was a forking with that network, and so we're learning a lot already. We're going to be restarting that network a couple times at least, just so that we have good coverage of a coordinated Genesis event. We want to make sure the chain's going to start correctly. We're working on promoting Prysm to a beta and eventually version 1 release, so production release. Right now it's an alpha. And then finally, we're going to be releasing the ETH2 Phase 0 mainnet later this year. So that's really, really exciting. Now, if you'd like to get involved, there's a lot of different ways, right? So you can check out our onboarding portal at prylabs.net, read our documentation, check out the code, read it all for yourself. Come to us on Discord, ask questions, and check out the API. Build on top of ETH2 if you're looking for, a project to work on, or just trying to get a better understanding. Building a tool on top of Phase 0 will be a really great way to do that. And that's it for my slides. So I can leave this up, and we can take questions.
Wow, thank you very much. I think it was so valuable. I wish half of the journalists that are knowing about when ETH 2.0, if they could at least understand the whole canary analysis and so much testing over testing before you release any feature would be amazing for this space. But having said that, I think people do have questions. Let me try to organize, but maybe if we could start an array, index 0, And each person that has a question just put an integer after the other, and maybe like a hashtag of what is this question about, if it's regarding the testnet, if it's regarding the chain, the architecture. So Preston and Terence can guide and open the microphones of you guys depending on the questions. I always have a million of them, but I would like to start with the question that I asked one of your guys, Ivan. And he was the first person that gave me my first 32 ETH so I could join the testnet. But I'm always fearful if I should actually deploy resources of my laptop, my only baby, to run a node. So I'd like you to please explain the importance if you need more nodes and why. And also, I remember he said around like 10 gigabyte, at least 2 gigabyte of RAM. Is this going to consume all the Wi-Fi in my house, or can my parents still watch Netflix while I run a node for Topaz?
I can take on that, and maybe Preston can fill in after. So personally, I have been running about 4,000 validators on my local setup. And this is a laptop that I also do work on. I also do a lot more things on this laptop. I also watch YouTube videos here and there. And we have come a long way. We used to be probably like 6 to 7 gigabyte. And now even with 4,000 validators, it's less than 2 gigabyte. And even if you just run 1 to 2 validators, it's probably gonna be less than 1 gigabyte at the most. And yeah, so definitely come a long way. And Preston has been running on his Raspberry Pi as well. That's another great option. He runs about 2,000 validators on his Raspberry Pi 4. And a lot of people have been running on their laptop here and there, no issue. And yeah, it's definitely something to try. But for mainnet, if you want to use your if to use real money, I wouldn't recommend to use your laptop just because of like when things happen, a software update, and then your laptop restart, and then you lose money, right? So for mainnet, I'd recommend something that's more reliable and something that has more uptime building.
Thank you so much. So there are still advantages of running a node on Topaz and helping the network. It's definitely something good. We should try.
Definitely. We definitely like your feedback. We definitely want to hear what's missing. So definitely from all the angles, we should be running nodes. Everyone should be running nodes. Yeah.
Yeah, it's also a great opportunity to get some practice in before mainnet comes around. So you can learn what works and doesn't work for you. You can treat it as real money, even though it's not. And you can watch the earnings or the penalties if you're offline and kind of get a good grasp on how it's going to work. Especially if you want to be there at day zero, it's going to be really helpful for you and also helpful for us because we get that user feedback.
I have a quick question. When you mentioned like the node to beacon node, the beacon node then sends a block that says for 5 minutes with that node. If that node is myself and I go offline, will I be slashed? Is how bad it is, and how often do I need to advertise before I go offline, or can I just switch off the computer anytime and without any damage?
Right, that's a great question. We get that a lot. So it's important to understand there's penalty and there is slash. There are two different terminologies. Both of them cause you to lose money, but getting slash is a lot worse in terms of you lose more money and then you will get kicked out from the validator pool. That means that you cannot validate anymore. You can only withdraw your money. So let's distinguish what these two are. Right. So getting penalty means that you are offline, just like what you said. Like, for example, my laptop was offline for an hour, I get penalties. And penalty, it's not too bad. You essentially just lose the rewards that you would have been getting if you were online. So let's say just throwing a random number, I'm supposed to get 8% a year, and then let's say if I'm offline for a year, I probably lose that 7 to 8%, right? versus getting slash means that you are actually voting on two truth, right? That means that you are actually purposely trying to harm the network. And let's say in that case, you will get slash anywhere between 1 to 16 ETH, and then you will get kicked out.
I see. So people lose the chance to win, but it's not that bad versus like when you do something wrong, then you're out.
Right. Right.
Yeah.
That's correct.
Super, thanks. I'll pass the ball to Alexei, because Alexei, you have some questions regarding this Hirumi BLS. Do you want to open your microphone and ask, or maybe Preston was already helpful?
Okay, it takes time to find the mic button. That is a question. What BLS you will use at your client? And as far as I saw, you will use Hirumi. Can you explain why? Why it is your choice?
Yeah, sure. So we're going to use Hirumi's BLS library because it's fast and it seems to work. It hasn't been it hasn't gone through a formal security audit that I know of yet, so we are not fully committed to it yet, but that's sort of what we're using at the moment. Also open to other options if there's something comparable to the speed that we need to support mainnet configuration, because doing BLS signature aggregation and verification is a lot of what the Beacon chain is doing. So it's really important that it be performant, but also secure. So at the moment, it's looking like Hirumi, but open to other suggestions.
Thanks a lot.
Brazilian community leaders. And I'm talking to Jeff, Solange. Any questions from your side? So far, so good. Yes, they both have been running nodes. They use Get on a daily basis. So they are also very advanced developers that do have Get on their laptops running most of the time for their jobs. Let me also ask regarding like, so it's as easy as joining the Discord to get Ethereum, just go to the faucet and then start running the nodes. So we shouldn't be like much complicated to be part of that.
That is correct. Yes, we have a participation site, and I can link to it in a little bit. So follow 5 steps, and then you can either use a script, or you can use a Docker image, and you can start a node. We also have a great documentation site as well. Shout out to Celeste, our wonderful tech writer for that. So there's a bunch of FAQs there. There's a bunch of tips there. There's a bunch of essentially just like guides there. So yeah, definitely check those out.
Very nice. I'm also happy that you mentioned there's a lot of community engagement all over the world. I guess you probably have a very strong network of people running nodes that you can count on. How is geographically? Or there are more people in Asia, or people actually decentralized? Like, who are the people that are making it happen?
Okay, question. So Ethereum is a global effort in general, and specifically for ETH2 and Topaz, we have the ETH2 stats site, which actually has a map. So I'll link that in the chat now, and you can really see that it's sort of all over. So primarily within the US and Europe, but there are a few. There's one person in Buenos Aires, and there's some people in Asia, one person in the Middle East. So there's kind of a pretty good distribution. We're hoping this grows to be a more vast network of users, at least for the multi-client testnet before we go to mainnet, so that we can get a really great test of, you know, passing messages globally across different you know, internet latencies and internet service providers, and passing messages all the way across the world. So kind of hoping to get some diversity there for sure.
I guess people are really pleased with the presentation. You got a lot of cheerful replies from the group over here. I guess everybody's very, very pleased. But let me ask about the bad guys, the ones that are trying to manipulate either on purpose or just by chance, that they are trying to bring the network down or make validator collusion. How do you actually block them? Is that by IP address? Like how do you know? Just people can just deploy a new VM and start all over again, and you guys are not going to know who's who? How does it work?
So there's multiple levels of protections here. So I can start by going probably like a layer down approach. So we can first start at the networking layer, right? And the networking layer, the typical thing you see is the DOS attack, right? So people can spam you with blocks, people can spam you with attestations, votes, right? So we do have some prevention in place for that. The spec does a really good job on preventing DOS from that perspective. Essentially, you will fast verify that the blocks are legit, the votes are legit, and then we will not process duplication of the blocks. So therefore, you can prevent from the networking layer. And then there is also the consensus, and then there are also the state transition layer, right? You don't want to pass a bad block into the state and then think that the state is valid at the end. So therefore, we do have a lot of steps to verify that, to make sure that the bad blocks are indeed being ruled out before passing into the state. And there's a lot of testing that goes through it. And then all the client code are undergoing audit right now. So we're definitely, so essentially all the code will be audited. And then the spec is almost audited via the formal verification team as well. So basically we want to make sure the math is sound, and then the state transition logic is sound from that regard.
So in the end, we all win with a stronger network after the code is fixed, and then we all learn with also by.
Right. Another thing, like I said, there's also randomness built in within it, right? So the randomness here is unpredictable, and then it's also unbiasable in a way. So people cannot manipulate the randomness, right? So in order to attack, you need to basically hold 51% of the network, which is a lot of money to do that. And then even though if you do attack, you will end up burning the money, and then like you will end up losing that money. So yeah.
Anybody else? Any kind of questions? Just, you're welcome to unmute yourself, even if it's just a word of thanks for their presentation. You're very welcome to express that.
Thanks a lot, Terence and Preston, for your time. It was awesome to have a high view of Prysmatic Labs and other plans on Ethereum 2.0.
Cool. Thanks so much for having us, and thanks for all the interesting questions. This has been really fun, and I wish as I said at the beginning, I wish we could do this in person. It would be great to meet all of you in person, but it's great to be able to do this, and maybe next year we'll do it again. So thank you.
Well, in the name of our community, I really appreciate that you took so much time to explain from the basics to the what's going on yesterday, why the network went down and the forks. It was very valuable to all of us. I hope you can see some of us in the Discord channel and enhancing the network. And thank you very much for coming to Ethereum Sao Paulo. Hopefully, you're going to go on the live tour next year. Just showing the benefits of ETH 2.0 that you're building so hard. And it will be great. So keep in touch. I usually use this blockchain Juju on Telegram. That's where I keep most of the Brazilian developers around. But they do have an amazing Discord channel where a lot of the news and what's been going on, from blog posts to like new tests and features. So do not wait to get that. And also I'm going to publish the links to that last slide that you presented to the community as well. But I appreciate the time, the attention, and thanks for being with us.
Thank you so much.
Beleza. Brazilians that want to still get around and have a get-together, we're here. If you want to talk a bit of Portuguese, não sei, we can also introduce our next Ethereum meetup. So we have already someone that joined Ethereum not so long ago and was able to already collect some precious hackathon prizes. And this person is going to be presenting their experience in Ethereum. In such a few weeks, he was able to learn so much. And I think this is very valuable for the community of non-Ethereum developers. Where did he find the tools and all that? So this is coming up on June 15th. And sei lá, queria saber de vocês, pessoal. Did you like? Foi legal? Do you want me to switch to português? What works? Okay, so I guess we're going to see each other next month. Muito legal, muito obrigada, Eduardo, pela participação. And you know where to find us online. Valeu, Fernando, muito obrigada. Tchau, pessoal. Então, até a próxima. A gente se vê em junho para o próximo Meetup. Muito obrigada.